Sorry, we got cut off. Part 2. What part changes in 5 and 6? Your K. What can you conclude about the effects? K shifts your graph vertically, up or down. A vertical translation occurs when your K is positive, and a vertical translation occurs when your K is negative. And now here, the function graph below is a reflection of the parent function. A reflection occurs when now the value of A is negative. Remember that the parent function, the absolute value of x, A was always a 1. So now that A is here is a negative 1. H is 0, K is 0. So it's the exact same graph as a parent function, just it's called reflected over the x-axis and it points down. Some differences here. Domain is still all real numbers. Since the highest point here now is 0 and it goes down, range is now y is less than or equal to 0. Vertex is still 0, 0. Axis of symmetry is still x equals 0. X and y intercepts are both still 0, 0. But now the increasing and decreasing are different. It is now increasing here on the left, decreasing on the right. -2, -1, 0. These numbers are going up before 0. So when x is less than 0, and then it's decreasing 0, -1, -2 after 0. So when x is greater than 0, it's when it's decreasing. So some conclusions here. What is the relationship between the value of h and k in each function and the vertex? H is the x value of your vertex, and k is the y value of your vertex. What is the relationship between h and your axis of symmetry? H is the value of the axis of symmetry. So your vertex is h comma k, and axis of symmetry is x equals whatever h is. What type of transformations occur when we change the value of A? It would be a vertical stretch and a vertical compression. What type of transformation occurs when we change the value of h? It would be a horizontal translation. But remember, we always need to think of opposite value. What type of transformation occurs when we change the value of k? Vertical translation. And what type of transformation occurs when we change a to a negative number? It is a reflection over the x-axis. Then here, decide if each statement is true or false. If it's false, write a statement that would make it true. If f of x was translated 3 units to the left to create g of x, that should be false because that should be horizontal 3 units to the right. F of x was translated 4 units up, that is true. It was vertically compressed. A is greater than 1, which makes it a vertical stretch. So this is false. Is the vertex a positive 3, positive 4? True. Is my axis of symmetry x equals 4? False. Should be x equals 3, the h of your vertex. Also, some things that are not in this packet. How do A, H, and K affect your graph? So just automatically looking at this graph, I can take out my vertex. I know it's a negative 3, positive 4, and it should be pointing down. So negative 3, 4 should be the highest point because I know it should be pointing down. And then I can always plug in 0 to find my y-intercept. So 0 plus 3 is 3. The absolute value of 3 is 3 times negative 2 is a negative 6, and then plus 4, I know my y-intercept is negative 2. And then since my axis of symmetry folds it in half, my y-intercept is 1, 2, 3 units to the right. I can do another point 3 units to the left, and I can then draw my absolute value function. So this would be shifted 3 units to the left, 4 units up. It is a reflection over the x-axis, and it is a vertical stretch because A, 2, the absolute value of A, which is a positive 2, is greater than 1, how it says it down here. How can you use the constants to write a function given a graph? So first, from the graph, identify the vertex. It is 4, 1, so h is 4 and k is 1. Then find any point from this graph. I'm going to use this point right here, which would be 3, 4. So that would be my x, and that would be my f of x. So 4 equals, A is what we're trying to find, absolute value of 3 minus 4 plus 1. 3 minus 4 is a negative 1. Absolute value of negative 1 is 1 times A is A. And then to get A by itself, A equals 3. So now that I know my A, and now that I know my vertex, I can now write it in vertex in standard form, which is A times the absolute value of x minus h plus k. So f of x equals 3 times x minus 3 plus 4 would be my absolute value function for this graph. And then just to do another letter A, an example, write a function for the graph shown. Again, find the vertex first. It's negative 1, positive 2. Find another point on that graph. I'm going to use 1, 5. Find your A first. So again, that's my h, that's my k, that's my x, and that's my f of x. So 5 equals, remember that this is an absolute value standard form. 5 equals, we need to find A, my x value 1 minus a negative 1 plus my k, negative times negative, a double negative makes a plus. 1 plus 1 is 2 times A, absolute value of 2 is 2 times A is 2A. Subtract 2, 3 equals a 2A, divide by 2, and A equals a 3/2. So using my vertex, f of x equals a 3/2 times the absolute value of x plus 1 negative, going in where I already have a negative, plus 1, and then plus 2 would be my absolute value equation for letter A.